So let us talk about polar coordinates. Polar coordinates. Well, first of all, recall that from algebra, from what you learned in algebra and pre-calc, we talked about only x, y plane, or another name for it is a rectangular plane or Cartesian plane. Cartesian plane. So remember that here you have your x-axis, here you have your y-axis, and you have your particle moving from one position like x1, y1 to another position x2, y2. This is my particle, whatever it is, it's a fly, it's a bird. It doesn't matter whatever that particle is. This particle is moving in xy plane, rectangular plane, Cartesian plane. But in math, we need other coordinate system. One of them is polar coordinate. In math, we need other coordinate system. One of them is polar coordinate. Okay, so how do we define a polar coordinate? When you're talking about a polar coordinate, any point in this new system is denoted by the very first element is r, the second element is theta. What is r? R is called the directed distance. R is called the directed distance. What about theta? Theta is the directed angle moving counterclockwise. Theta is called the directed angle moving counterclockwise. There we go. So give us an example. You introduced a new system, polar coordinate system. We know about Cartesian plane, xy plane. How do you introduce this polar coordinate system? For example, if I ask you to graph 2 and pi over 3, you're going to say that, hey, I'm dealing with a polar coordinate. 2 and pi over 3 is a point in the polar coordinate system. R and theta. Well, I have R and theta, and I'm going to assume that my origin is here. And I'm going to assume that, well, my horizontal line on the positive side represents the length of R. Okay, so this is my O, and suppose this is point P. Point P. The length is 2. R is 2. 2 units. So R is 2 units. Let me write it here. R is 2 units. Okay, so take it 2 units. Suppose this is the 1 unit and this is your 2 units. Now, the angle associated is pi over 3. It means that I need to take this 2 unit and rotate it counterclockwise pi over 3. So whatever this guy has the initial position, I'm going to take this and rotate this pi over 3 counterclockwise. So this guy, this point is 2 and pi over 3. So this point represents 2 and pi over 3 in polar coordinate world, polar coordinate system. Okay, give us more examples. Sure. Now, suppose I ask you to graph the following. Graph your point, let's call it B, for example, point B, with first coordinate 3 and second coordinate as a negative number, negative angle, negative pi over 6. Well, what do I have here? I have a polar coordinate system representation for this point. This is R and theta. So as you can see, your length is 3 units and your angle, guys, the angle is negative. The angle is not positive. So take a look at this. So suppose your origin is here. This is your origin and you have your polar axis here. Polar axis. So first decide on 3 units. 3 units, okay. Suppose my 3 units is just right here, 1 unit, 2 unit, 3 units. So this is the initial position of the point B. This is initial position with 3 units length. Now you have negative pi over 6. It means that you have to move clockwise. This is going to be your point B, point B, 3 and negative pi over 6. Okay, another example. This example says, graph the following. Graph point C with 3 and 11 pi over 6. Okay, 11 pi over 6. What do I have here? Well, first start by the origin. This is my origin, and this is my polar axis. Okay, this point in polar world has first coordinate R. It means that the length is R and the angle associated to that is 11 pi over 6. Okay, the same as before. 3 units and my angle is now positive angle. Very good. So what should I do? I should start by taking 3 units, 1 unit, 2 unit, 3 units. This is my initial position of the point. And then it starts rotating counterclockwise 11 pi over 6. So 11 pi over 6. Very well, 11 pi over 6. This guy's going to be here. Perfect. So we'll get rid of this. We don't need this anymore. The only The only part that you actually need to represent is the last part. C, 3 and 11 pi over 6. Just note that 11 pi over 6 and negative pi over 6, they coincide. So as you can see, these 2 points, if you just forget about this rotation, the whole rotation, these 2 points representing the same polar coordinate format for the same point. So these 2 points coincide, and we can verify that. So in general, let's erase this and write down the following for you. In general, in polar world, a point like r and theta can be represented as the following. Represented as, the very first option that you have is r and theta plus minus 2 pi n, or since r is directed distance, it means that you can associate a negative sign to it as well. Negative r and theta plus minus 2n plus 1 times pi. So in polar world, if you have a point like r and theta, you can represent this point by r comma theta plus minus 2 pi n, and it's just an integer. Or since r is a directed distance, it can take a negative sign as well. Negative r, and the angle theta is equivalent to theta plus minus 2n plus 1 times pi. For example, suppose we have the following. Let us have the point 3 and negative 3 pi over 4. Okay. This is r and theta. I have a point in polar world, r and theta. Following the formulas, 3 and negative 3 pi over 4 can be represented by 3 comma negative 3 pi over 4 plus minus 2 pi n. Okay. For example, if I plug in 1 for n, if n is equal to 1, then 3 and negative 3 pi over 4 has another representation, 3 and negative 3 pi over 4 plus minus 2 pi. These points, they are representing the same location, the same position. You can just use plus, and then you get 5 pi over 4. 5 pi over 4, or you can use minus negative 3 pi over 4 minus 2 pi negative 11 pi over 4. 11 pi over 4. These points, they're all the same. Or you can follow the second formula. We can also write down 3 and negative 3 pi over 4 can be represented by the second formula, negative r, so it gives you negative 3 comma theta, which is negative 3 pi over 4 plus minus 2n plus 1 times pi. So suppose n is equal to 1. If n is equal to 1, you have the following case. You have 3 negative 3 pi over 4, which can be equal to negative 3 comma. So if n is equal to 1, you get negative 3 pi over 4 plus minus, you have 3 pi, and then you can add, you can subtract 3 negative 3 pi over 4 can be equal to negative 3 comma. If you just add these together, you get 12 minus 3, 9 pi over 4, or negative 3. And if I just do the subtraction, I have negative 12 minus 3, negative 15 pi over 4. These points, they are all equivalent to each other. If you graph them, they show the same position in the polar coordinate world.